A method of testing the plasticity of soil is referred to as the toughness test. Water is added to about 1/3 of a cup of the fines portion of the soil sample. Those are the particles that pass through the number 40 sieve. The sample is then rolled into a 3 millimeter, about approximately 1/8 inch diameter thread. The thread of soil is then folded and re-rolled repeatedly. As you do this, the moisture content is gradually reduced and the soil specimen stiffens and finally loses its plasticity. It will ultimately crumble when the plastic limit is reached. After the thread crumbles, the pieces should be lumped together and a slight kneading action should continue until the lump crumbles. The tougher the thread near the plastic limit, and the stiffer the lump when it finally crumbles, the more potent is the colloidal clay fraction in the soil. The toughness of the thread that forms when the soil is rolled will identify the fines as either silt or clay. Generally, if the thread is obtained easily, then the soil is clay. If the thread is difficult to obtain, the sample is silt. The inability to form thread or the weakness of the created thread indicates a plastic silt. A weak, spongy thread indicates silt, either organic or inorganic, with a high liquid limit and a very low plasticity. A firm thread indicates low plasticity clay, and a tough thread indicates highly plastic clay. Now that you've performed the tests on our soil sample, what do they tell us? Identifying the soil's types is a major factor in determining the type of foundations that can be used. In general, the better the soils, the higher the bearing capacity, and the smaller the footing would need to be. As the soils range from good to poor, the cost of the foundation system will go up. In addition, once we know the type of soil found on our site, we can determine its bearing capacity by referring to this chart. These are commonly used values and may be referred to as the presumptive soil bearing capacity. Also note that the drainage characteristics of the soil types are included. A site designer needs to know the types of material he or she is working with when planning a building substructure. If you would like a copy of this chart to share with your students, please pause the lesson and press on the link. Resume the lesson when you have the document on your computer. If the soils at the site are not suitable to carry the foundation loads, the site can be altered. One alteration which could be done is to compact the soil to increase the density and therefore increase its bearing capacity. Or the contractor may need to bring in engineered fill. In this case, the old soil must be excavated and removed before desirable soils can be trucked in. It is also possible that there is a ledge. In this case, a contractor might have to resort to blasting in order to remove the rock. These and other options all add to the cost of the construction project. A useful chart for your students' reference is the Soils, Types, and Properties chart created by the U.S. Corps of Engineers. This chart lists the types of soils, the commonly used letter code, color, description, value as a foundation material, and drainage abilities. Once again, if you'd like, pause the lesson to obtain the chart. Take a moment to look it over and feel free to share it with your students. Once all the tests have been completed and the soil's properties have been identified, it's a good idea to create a document which puts all the information into one place. This document should describe the significant properties of the soil either in a paragraph or a list form. The description would be included on the drawings for a given project. If one were unable to obtain a specific soil property, that property would not be listed in the description. Here's one example of a description of a soil sample. We are again supplying a copy of the template if you would like it. Pause the lesson and click on the link. Activity 5.